We're going to be looking at higher order derivatives, and that means that we're not just going to take the first derivative, but we're going to take the second derivative. So this y double prime right here means take the second derivative. So the first derivative of 2x plus 1, the derivative of 2x is 2, and the derivative of 1 is 0. Therefore, the second derivative is equal to 0. Alright, in this example here, we've got y is equal to x to the 10th plus 5x plus 1. So we want to take the second derivative, and that is, we're going to first have to find the first derivative. So we take the 10, bring it out front, subtract 1 from the exponent, and the derivative of 5x is just 5. Now we're going to be taking the derivative of this. So you take the 9, bring it out front, and 9 times 10 is 90, subtracting 1 from the exponent, which gives us an 8. So the second derivative is 90x to the 8th. Alright, in this particular one here, we've got y is equal to x over x minus 1. So we're going to be using the quotient rule. And the derivative of the numerator, the derivative of x is 1. Rewrite the denominator minus the numerator times the derivative of the denominator. Derivative of x minus 1 is just 1. And it's all over the denominator squared. So now what we're going to want to do is clean this up. And this just becomes x minus 1 minus x. So the x's end up canceling out, and we're just left with the negative 1 up here in the numerator. And since we want to find the second derivative, that means we need to take the derivative again. And what I do is I go ahead and bring the denominator up into the numerator. And I do this because we just have a number up here, okay, just a constant. And it's just a whole lot easier to do this as long as there's a constant up here and not any variables that have to deal with involve x. Alright, so I take it to the top, it becomes negative 2, right? It's positive 2, bring it up into the numerator, becomes negative 2, law of exponents. Now we're going to go ahead and take the derivative. So take the negative 2, bring it out front. I'm rewriting this negative here, which I throw a 1 on so it doesn't look too confusing. And then we subtract 1 from the exponent, gives us a negative 3. And then you could look at this as taking the derivative of the inside and chaining it out, but the derivative of x is just 1. And of course that would be 0, so no need in doing that. Now what we want to do here is simplify this down. And that x is a negative 3, we're going to take that down into the denominator. We have a negative and a negative, becomes positive, so there it is, the second derivative. Alright, in this particular one here, we've got y is equal to x times x to the minus 4 raised to the third power. So this is going to be the product. We've got the product of two separate functions here. So the derivative of x is 1. Rewrite the second function plus rewriting the first function times the derivative of the second. So that 3, you bring it out front. Rewrite everything in parentheses, subtracting 1 from the exponent. And then the derivative of x minus 4, this time I do kind of show that, and chaining this out, and derivative of x is 1, of course derivative of the minus 4 is 0. And then we're going to simplify this down, and we get it into this form here. Now we want to take the derivative again, because we're trying to find the second derivative. So we go ahead and take the derivative of x minus 4 raised to the third power. Take the 3, bring it out front, rewrite everything in parentheses, subtracting 1 from the exponent. And of course, if you took the derivative of the inside and chained it out, it would just be 1. So we're good on that. Okay, this over here, we're going to be using the product rule again. We got the derivative of 3x, which is 3. And then I rewrite the second function, plus rewriting the 3x. And then we want to take the derivative of the x minus 4 raised to the second power, which means you're going to take the 2, bring it out front, rewrite everything in parentheses, subtracting 1 from the exponent, which just leaves us with a 1. Now you notice I put a bracket around this right here, and this is important. However, we didn't really have to do it here, but I went ahead and showed it anyway. If this were a minus sign right here, we would have to distribute this minus inside. And that means that you definitely need to put a bracket around there, but we need to move on. So we got to this point, we're simplifying things down here. Looks like I just dropped the brackets. Okay, don't do anything here. Multiplied across, so added like terms. There we go.